Okay, hello everyone. So this class is our final class of the fundamentals of environmental engineering science. So specifically, we're going to talk about the hazardous waste management. So we talk about the waste that's coming from the liquid phase, from the air, the gas phase, and also the solid phase. So there can be hazardous materials that's existing in all of these phases. So these hazardous material needs very special regulations or special processes to deal with them. Okay, so again, let's do a recap of our last class. So last class we mainly talked about the municipal solid waste, right? What is the average generation rate? So how much of them are being sent to the landfill, or how many of them are being recycled? And also, how do we manage these solid waste? And what is the design of the landfill, and also what are the considerations for these landfills? Okay, so there isn't a lot of engineering involved in the process, except that we need to track the numbers, right? Track the population, generation rate, and design or properly design these landfills. Okay, so we also mentioned a specific product that's coming out of the landfill, which is a leachate. We know that the leachate is basically concentrated polluted streams, and sometimes they can be hazardous. So this class we're going to talk about how we deal with these hazardous waste material. Okay, so the hazard or the hazardous materials are basically the materials that pose substantial danger. So they can be in the now or in the future. You see that there's a broader definition of the hazardous material to all of the human, plant, or animal life. This is similar to the definition of the air pollution, right? But the hazardous material are something that can pose substantial danger. So they must be handled or disposed with special precautions. So the EPA classified different types of these hazardous materials. For example, they have the type F. So the F means the specific waste that's coming from the non-specific sources. Class K represents coming out of the specific sources, right? P represents the chemicals that have acute toxicity, so on and so forth. But for all the materials that are not cannot be properly traced, they are categorized as the type D. Okay, so which are ignitable, corrosive, reactive, or toxic. So you can see that basically the hazardous waste will satisfy all of these specific wastes and also the broader definition, right? As long as they can be ignitable, corrosive, reactive, or toxic, they can be categorized as the hazardous waste. Okay, so basically, these four then will be the characteristics of these hazardous waste. Okay, so if I have a question of what are the hazardous material, then they have to be ignitable, corrosive, reactive, toxic. Okay, so we should choose all of them. Okay, so there are several important types of the hazardous materials, or very commonly seen hazardous materials. For example, the dioxins. So dioxins are basically species that have these aromatic rings, but also connected by two oxygen. So that's why it's called dioxins. Okay, so they are typically the byproducts when you are burning chlorophenols. So species or the organics that contains chlorine inside, or you're burning herbicides, insectables, or preservatives. So why do we burn these materials? So in last class, we talked about incinerating the solid waste, right? So there might be some of these materials in those solid waste, and once the dioxins are being generated, it's very difficult to process or to capture them. So there are also other types of the all the subtype of these dioxins. So basically, it's showing this one, the TCDD, right? So this one. So this is the most toxic chemical from in the dioxin family. Okay. So they are persistent, bioaccumulative. So they can cause cancer, and there's no safe dose. Okay. So which means that the safe dose is 0. Once they are being emitted, they're acute and they are strongly toxic. Okay. So, for example, in Missouri, this is something that's related with the history of our state here. In 1983, the entire population of the Times Beach was executed. Basically, they are transported somewhere else. evacuated from this city here and relocated because of the widespread dioxin contamination from spraying the waste oil on unpaved road and to suppress the dust. So basically, a lot of these oil and debris were incinerated at 1250 degrees at high temperatures. If these oil contain chlorine inside, they can generate dioxins. Okay, so the off gases were buried in a secondary combustion chamber at further higher temperatures and then cooled in a wet gas cleaning system to remove the particulates. But so basically, these residue ash were either buried or retreated. Okay, so this cost 110 million remediation cost. Okay, so you can see that dioxins are being generated from these high temperature combustion processes, and people have to get evacuated from the place that's nearby these pollution sources. Okay, so people actually waited how long? 16 years until this region was reopened. Okay, so this is showing a picture of the incident during that time, and now we know that the state parks are reopened because basically after a long time of processing, these dioxins are either being transported or, to the broader area, so the concentration becomes lower, or they're being degraded into other species. Okay, so the other type of the hazardous material is the PCB. Okay, the PCB stands for polychlorinated biphenyl. Okay, so this is also related with the aromatics. So but typically there are two aromatic rings, and also it's connected with the chlorine on it. Okay, so these are the PCB. So they are potential to cause the human cancer, right? It's banned in 1977, and it's mostly coming out of the fish, by consuming fish. Okay, so in terms of the regulation of these hazardous waste materials, so people basically design new policies for dealing with these new hazardous waste. Okay, so there are congressional actions to regulate the generation and disposal of these hazardous waste, right? So people can conduct different processing procedures by following these different acts or different regulations here. Okay, so for example, if you want to remove these new types of hazardous waste, you should use the tracking method, right? The cradle to grave approach to reduce its emission from the sources and also to process these hazardous materials after they are being generated. So there are requirements on the generator, right? So for generators or industries that producing 100 kilogram of hazardous waste or 10 kilograms of acutely hazardous waste per month, they need to document and track these hazardous waste and also obtain an EPA ID number for better tracking of these hazardous materials. So there are also regulations on transporters. We know that after these hazardous materials are being generated, we need to use trucks or use railway to transport these material away, right? So they must comply with the DOT, Department of State regulations, and also the EPA regulations. And local officials have to have the special authority to handle these transportation accidents. So further, there are processes or procedures in terms of the treatment, storage, and disposal. People also call them, or TSD for short. Okay, so the treatment means to reduce the toxicity or recovery. Storage means temporarily hold these hazardous material, and disposal means to put the waste into or on any land or water. Okay, so there are administrative requirements to properly conduct these TSD processes. There are also technical requirements for the TSD process to minimize the threat potential. Right? For example, you need to monitor the groundwater to monitor the concentration of these toxic or hazardous material, and closure and post-closure requirement, right? People have to keep the site and take care of it for 30 years. So if the pollutants are being emitted out of these storage sites, people have to be responsible for their hazardous materials. And also there are financial requirements to make sure that funds are available for problems after the closure. It's not like after you generate these hazardous material, you can go away, right? You have to keep monitoring, keep maintaining them for 30 years, and also to have available funds to deal with the accidents. Okay, so for certain waste, there's also land disposal restrictions to process these materials. So we have a question. What are the major technical requirements of a TSD facility? So they have to follow the groundwater monitoring, right? They have to come up with a plan regarding the closure and post-closure requirement, and also there are financial requirements to make sure that the funds are available after the closure. Okay, so that's why we should choose D here. And there are also regulations in terms of the underground storage tanks. For these storage tanks, sometimes they can store these hazardous materials. So it's like the septic tanks that we talk about, the wastewater treatment, right? So we have to prevent the contaminants or hazardous materials from penetrating these tanks and then going into the groundwater. Okay, so these tanks have to include the systems of tank piping and ancillary requirements. So all systems have to include corrosion protection, which can be accomplished in 3 ways. So this can be done by construction of fiberglass reinforced plastic. They can use steel and fiberglass reinforced plastic, and or a coated steel tank with cathodic protection. So people can use these materials to deal with the corrosion problems. So all the systems have to be installed by certified installer and must have spill and overfill prevention equipment and leak detection systems. So we don't want to build a septic tank or build these storage tanks, but fail the safety issue, right? Fail the safety inspection there. So they have to be leak-free. So and also for some of these devices, they have to have a secondary contaminant with interstitial monitoring. So they have to have basically a secondary protection mechanism to prevent the leaking of these materials. So in terms of the management of these hazardous waste, there are basically multiple ways to deal with them. For example, we have to control the source, which is the waste minimization. Okay, so basically people should identify the waste and find the causes. So once we find the reason for generating this waste, and we should find a solution for dealing with this waste here. So people will use the mass balance calculation, right? So basically, by tracing all of the emission points of the hazardous material, so we can conduct mass balance, right, to find out what is the emission source. And then once we get the emission source, we can find a solution to deal with the minimization of the waste. So we can also use the waste exchange. Basically, after these wastes are generated, we can extract some profitable materials. That's why one person's trash might equal to another person's treasure, right? So we can extract the components coming out of these hazardous materials. Maybe there are industries that will use these hazardous materials for chemical processes. So we can also recycle these hazardous materials. We can use or reuse these materials basically as an ingredient to make a product or as a substitute for commercial product. We can reclaim them to recover a useful product, to recover lead from the spent batteries, and also regeneration of the spent solvent. Okay. So in terms of the treatment technology of these hazardous materials, so similar to the organic materials, when we're dealing with the drinking water treatment or wastewater treatment, we can use these biological treatment. So basically use these microorganisms to deal with them, right? So, but the problem is that for some of the compounds, for example, the halogenated compounds, which are basically the the organics that contain chlorine inside, for example, they're resistant to the biodegradation. So under this situation, we need to use some other methods. But in general, for a lot of the organic materials, we can use these biological treatment to deal with that. So we need to consider the environmental factors, for example, the dissolved oxygen, pH, nutrients, temperature, basically to control this biological reaction, right? This remind you of the wastewater treatment process, right? So basically, we can use those bacteria to deal with these organic species. So we should provide adequate condition for bacteria to grow and remove the pollutants. We can use the activated sludge process. Again, this is for wastewater treatment, trickling filters, so basically other species, right? Other processes. So in terms of the chemical treatment, so for species that cannot be easily biologically degraded, we can use chemical treatment to deal with these pollutants. For example, first you can control the pH, right, to neutralize the hazardous material, and then also to remove some of the species there. So we can also use oxidation, basically to pump in oxygen or air to deal with the organics in there. So for example, we can use the cyanide using the chlorine or ozone. So basically, we can control the pH of these hazardous stream here. And for higher concentrations, we can use the electrolyte oxidation. So we can also use the wet air oxidation, so to generate, to pump in air, but at a high relative humidity. Okay, so but the issue for this method is that although it's very cheap, but it's not a complete oxidation, complete removal process. So there are also advanced oxidation processes, for example, to use ozone or hydrogen peroxide to deal with these hazardous materials, right? Once we have these OH radicals, they're really oxidative, okay? A strong oxidizing agent which can oxidize all kinds of organic pollutants. So people can also use the precipitation method. So basically to raise the pH, so basically to make the solution or make the stream more basic, right? Less protons in this stream here. Or you can use other salts to precipitate these metals. For example, if we're talking about the lead, zinc, silver, copper, nickel, and vanadium, right? So we can basically enhance the pH to introduce the OH into the solution, right? To precipitate these organics or these heavy metals, right? To remove these hazardous materials. And finally, in terms of the management, we can use the reduction method. So this is oxidation reduction process, right? So basically, you can control the pH and also control the oxidation process to basically, for example, you can remove the chromium. That's by pumping in the sulfur dioxide, right? The sulfur dioxide can be oxidized by these chromium into the sulfate, and we know that the sulfate or the chromium sulfate is precipitable, which has a low solubility, right? So we can remove these heavy metal from the water. So a quick question: adjusting pH can remove many heavy metals because, so basically at a different pH range, we can remove them by precipitation, right? The pH is not going to oxidize anything or reduce anything, so they cannot follow this method. So it's just going to use the method of A here, okay? So we can also use the physical chemical treatment. So this is talking about, we have been talking about the chemical method, right? So we can also use the physical chemical treatment, where we can use adsorption, which is, for example, using the activated carbon, right? So we can use the high surface area to absorb these pollutants in the polluted stream there. We can also use distillation, evaporation, right? Air striping. So the air striping means we can introduce air to remove the organics there, to oxidize those organics in the stream there. We can also use the solvent extraction, so the contaminants can dissolve more in one solvent than the other. So it's talking about the dissolution in different types of the materials. So people can also use more complex processes, for example, the ion exchange process. So we can design the device that contains the exchange resin, right, to replace the toxic ions with non-toxic ions. So we also talk about this process when we're learning the drinking water treatment, right, to further remove the ions that are in the water. So we can use this ion exchange process to purify the water. So we can also use that to remove the hazardous materials. And people can also use the electrodialysis, right, to remove the ions and desalting food products. Okay, we can also use these reverse osmosis. This is talking about the building up a membrane where if we have a membrane that has a very small pore size, then only certain type of ion can penetrate through. Okay, so basically use a high pressure to filter the water through, right? So basically, if you have a membrane that can only allow a water molecule to pass through, then we know that for a lot of larger ions, for example, heavy metals, they will just stay in the polluted stream there, right? So finally, we can use the incineration method. So again, it's similar to the solid waste management, where we convert these hazardous waste directly to heat and energy, right? But of course, we need to think about the pollutants that's being generated from this process, because besides the carbon dioxide and water, we're going to generate particulate matter, sulfur dioxide, NOx, and also a lot of, for example, halogenated organic compounds and heavy metals. Okay, so of course we need further treatment of these species. Okay, and also do remember that if the combustion is not complete, then it's going to generate carbon monoxide, hydrocarbons, aldehydes, ketones, so many different types of air pollutants, and we're going to deal with the air pollution control of these toxic species. Okay, so the design criteria for this incinerator for processing these hazardous material is that it must remove 99.99% of the principal organic hazard components. Okay, and here is showing a diagram of the incinerator consuming the hazardous materials. So basically, it's similar to a coal-fired power plant or the incinerator for the solid waste, right? So you can see that a lot of gas pollutants are being generated. And then basically we'll introduce more species to remove these gas pollutants by conducting reactions here. But also we need to deal with the emission of these toxic gas species by building up the air pollution control devices. Okay, so this is another diagram showing the process that's dealing with the solid waste or the hazardous material. So you can see that here actually we use the water scrubber to remove some of the pollutants there. We use the electrostatic precipitator. Remember, this is for dealing with the particulate matter, especially in the smaller size range, right? And finally, we can introduce them through the stack. Okay, so again, for the design of these hazardous waste incinerators, we need to guarantee that the removal efficiency for the principal organic hazardous constituents have to be higher than 99.99%. Okay, and in terms of the HCl, the hydrochloric acid, less than a certain amount, right? And in terms of particles, there's also requirement for the incinerator there. And also, we need to consider the PCB, which is the polychlorinated biphenyls. Okay, we introduce this as another example for the hazardous materials. Okay, so what should be considered when designing hazardous waste incinerators? So we need to consider the efficiency higher than 99.99%. We need to consider the emission of the hydrochloric acid, the emission of particles, right? We need to use D here. Okay, so for some of the devices that's controlling the hazardous waste, we also need to consider the stabilization or solidification process. So just think back on the wastewater treatment. So finally, we need to deal with the sludge that's coming out of the wastewater treatment, right? So for some of the waste, they have to be stabilized, okay? So stability simply means the degree of resistance for leaching, generating more liquids coming out of these hazardous materials, okay? So we can use lime, cement, or other chemicals for forming stable materials that can reduce the leaching. And in terms of the land disposal of these hazardous material, there are two options to do that. One is to construct a deep well, so basically inject these materials into the deep well and discharge to geologically secure formations. And also we can use a secure landfill, which is basically more complicated than the typical landfills, to locate above a natural barrier to prevent the permeation of these hazardous materials, and also an applied liner to prevent the permeation from below, right? Continuous monitoring and leachate treatment. And if accidentally the groundwater is being contaminated by the hazardous waste, then we have to think of ways to remediate this problem. So we need to talk about the groundwater remediation. So first we need to know what are the sources of the groundwater contamination. So they can come from the hazardous waste landfills, municipal landfills, septic tanks, mining and agriculture activities, so on and so forth. So the EPA provides the procedures for conducting these remediation process. So first they will do a preliminary assessment. So basically they will take samples of the groundwater to see whether that's been released. Then they'll also check if there is an immediate danger there, right? And also they'll evaluate whether a site inspection is necessary. So in terms of if that's necessary, then they'll go conduct this inspection. So they will study what are the types of the hazardous material and the extent of the contaminants and its migration. They will use the hazard ranking system, right, to use different lists to decide whether immediate actions are needed. Okay, so finally they will come up with the remediation design and also the remedial actions there. So in terms of mitigation and treatment of the groundwater contamination, they can use the pump and treat method. So basically to extract water from the underground and then treat them and then pump it back or recharge into the groundwater system underground. Okay, so they can also use the in situ treatment using air striping. They can pump in air directly inside to oxidize those contaminants. They can also use the permeable reactive barrier using zero-valent ions. So this is a more complex process dealing with the hazardous materials. So here is a diagram showing this pump and treat method. Okay, so you can see that, for example, an industry actually accidentally caused a spill of the chemicals which are hazardous. Then they can get permeated through the unsaturated soil, right? They can also get penetrated through the groundwater flow. And once that happens, we know we have a problem here. For example, this is the contamination plume, right? So what we can do is we can construct a pumping well that goes deep into the groundwater system there and then extract water from below to the above, okay? And then the water can go through certain treatment facilities and then get recharged into the aquifer, recharged into the system here. So in this way, we can purify the water a little bit. But there's also certain considerations we need to make, right? For example, the recharge point have to be far away from the pumping well there. Otherwise, you're mixing the clean water back into the contamination plume. And so there are a lot of considerations in terms of the design process for the groundwater treatment system. Okay, so that's all for the contents of our last class. You can see that this is also a pretty brief content. So there's a lot of some concepts being involved, but right now we don't have engineering processes or design processes in terms of controlling these hazardous materials. Okay, so let's do our final review of this class, or of this entire class. Okay, so in this class, we talked about what are the methods we can use to treat these hazardous materials, and also what are hazardous materials, right? So there are 4 criteria that we can use, right? They have to be ignitable, they have to be toxic, right? There are 2 more, so just go back and then look at what the factors are. So why adjusting pH can remove many of the heavy metals? Because the higher the pH, some of the heavy metals can precipitate in the water, right? So we can convert them from the liquid phase or suspended ions into solids. And also, what is air striping, right? Pumping air through the contaminated water, right? Contaminated species, and then oxidize those organics inside. What are other physical chemical methods that we can use to treat the hazardous materials? What are the types of waste can be treated through incineration? What are the concerns for the incineration? That's the air pollution, right? What removal efficiency does it require? And also, what types of waste must be stabilized? So basically, we want to prevent leachate coming from the waste there. What is the EPA underground remediation procedure? How do we remediate the groundwater? Okay, so that's all for the contents of this class, and you can see that this is also all the contents of our entire class. So if we do a quick review of our entire semester, so first we basically recalled some basic concepts on the chemistry there. So we learned what is modality, right? And also what is normality, right? So we use those concepts when we're dealing with the water treatment. And then we introduced how the water or how the dissolved oxygen is being distributed in the river system or in all different types of the water systems. So more specifically, we talk about the DO-sag curve, right? So the oxygen are, once we dump in some pollutants in the river, right, we can see the dissolved oxygen will decrease and then come back because the air or the oxygen are being dissolved in the water. Okay, so then we learned about the drinking water treatment system. Okay, so or we can call them as, also call it as water treatment system for simplicity. Okay, so for the water treatment, we introduced the coagulation, flocculation, clarification. That is a major concept for treating the drinking water quality there, right? So we can also use filtration, right? And finally, we need to use disinfection there. And in terms of the wastewater treatment, okay, so there are not a lot of procedures being involved like the drinking water system because there's lower requirement, right? For drinking water, we have to guarantee that it's safe. But for the wastewater, we're not drinking that. It's just pumping back into the environment. So there can be some BOD left in the water there. So there are primary treatment and secondary treatment. And secondary treatment is required by the federal agency, right? So, and more specifically, the secondary treatment, a major type of it is the activated sludge process. We introduced how we can design those processes, okay? Then we introduced the air pollution, or the air pollution control. So we learned about how the air, what are the criteria air pollutants. So there are 6 types of criteria air pollutants, right? And how human activity is affecting the world, right? The climate change and also the ozone hole, right? So we introduced particulate matter, we introduced the gaseous air pollutants, for example, the sulfur dioxide and nitrogen oxides. So for these air pollutants, we also talk about their control methods. For particulate matter, we have cyclones, electrostatic precipitator, we can use filtration, right? And for these gas pollutants, we can use, for example, the pre-combustion method, post-combustion method, and also in-combustion for the nitrogen dioxide control, okay? And finally, we talk about the solid waste. And actually, this is solid waste. Okay, the solid waste, we talk about how should we recycle the either the material or energy coming out of the solid waste, or how we can design the landfill to store the solid waste. And we also talk about the hazardous waste in this class, right? So you see that hazardous waste will be more important, basically because of their higher toxicity. We need to design more policies or design more regulations to control or remediate these pollution problems. Okay, so that's all the contents of this set of lectures, and feel free to let me know if you have any questions. I hope you enjoy the entire semester. So if you didn't like it, also let me know so that I can improve in the future. And in terms of the final exam, it's going to cover the air pollution and also the solid waste together with the hazardous waste. Okay, so it'll be similar to the exams before. So focus more on the homework problems and also the exam problems, also the example problems in the textbook. And let me know if you have any questions. Okay, and thank you all for your participation and collaboration of the entire semester. I know that the situation is quite difficult because of the pandemic, and I hope that everyone is doing well at home and practicing the social distancing and doing good hygiene there. Wash your hands and stay safe. Okay. Thank you all. Bye.